Okay. Um, it's day 4 of Advent of Code. Exciting. Um, I'm going to go silent and read the question first, and then we can talk about it later. Space needs to be cleared before the last supplies can be unloaded from the ships, and so several elves have been assigned the job of cleaning up the sections of the camp. Every section, blah, 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 number right. And each of the elves is assigned a range of section IDs. However, as some of the elves compare their section assignments with each other, they've noticed that. Okay, for example, consider the following list of section assignment pairs. So force 2, 4, 6, 8. Yeah. For the first few pairs, the list means within the first pair of elves, the first elf was assigned sections 2, 4, sections 2, 3. The second elf was assigned section 68. Each assigned to right. And then the elves in the third pair each assigned 3 sections. One got section 5, 6, and 7. 3 sections. Third pair 5, 6, and 7, 7, 8, and 9, right? This example list uses single-digit section IDs to make it easier to draw. Okay. 2 to 8. Yeah, 2 to 8 and 3 to 7. Okay. Right. Put it close enough actually. Oh. Okay, so some of the pairs have noticed that one of the assignments fully contains the other. For the example, 2, 8 fully contains 3, 7. Right. Yeah. It's fully contained by 4, 6 in pairs, where one assignment fully contains the other. Okay, one elf in India in the pair would be exclusively cleaning section. Cleaning. Right. Consideration. In this example, there are 2 such pairs. Right? One elf in their pair would be exclusively cleaning. So these seem like the most. In need of reconsideration. In this example, there are 2 of such pairs. Okay. Right. Fully contains, not partially, right? Okay, in how many assignment pairs does one range fully contain the other? In how many assignment pairs That's one range fully contained here. Okay, makes sense. Um, so I'm going to start my we know how this goes. We have to rename this to solution pi before VS Code that's complaining. Yeah, and I already have some sample, template code here, that will basically make my writing this code faster. Basically, what it contains is how to open the test inputs and then the input that we're going to get from the data and from the question, sorry. So let's copy over this. Well, for now, let's not even copy that. Let's copy over the test input first. And for the first one, the answer was 2. For the test input, the answer is 2. So let's put over the test input over here. Save it. And then put the test input that session has to pass here. Right. Test output, sorry. And how do we pass this data? Basically, we have a list of 2 pairs. Each pair contains a starting point and an ending point. I would want it to be a list of tuples, right? Yeah, a list of tuples so that they could be used as ranges, right? So probably as the lines have been read, right? What I want to do is for each of them split. Let's not even split it, just remove yeah, split it by the okay. I know what to do. What I really want to do is build a list that contains a list of tuples, right? Like this. 2 ranges like that, right? And so forth. This is what I really want to build, something like this. So what I'm going to do is, since I already have it in this format, I want to turn it into this. What I'm going to do is for each of them, so basically iterate over for line in data, right? And what I need to do is first of all strip the trailing line, strip the trailing new character line. So let's strip that out of it. Yeah, so let's make that how do I yeah, just for each line dot strip, and once I have stripped that, I also want to split it into the pairs, right? So right, and after I have split it into pairs, right? What were they even called? Groups or pairs? I just call them pairs. For each pair or for each group in pair, yeah. And then so after I have split by the and then for each of them, I want to split by the hyphen and then de-stringify them. split by the hyphen character, um, and then after you've done that, basically you have to destringify it. Yeah, so that would be just one part, and what am I doing? I have split it by, let me just point it out. I have no idea what I'm doing here, so let me just print it out over here. Okay, let's print this one out. Right, so I'm definitely doing it right. So I have two for basically the first part of each of them. What I really need to do is put part A and then part B. Yeah, so I was doing it right. After I've done that, do the same thing for part B. And then put it inside some list which I'm going to create here. We are going back to our favorite variable, processed data. So this should do the trick. So now we can get into part one now that our data has been cleaned out. So that means, wait, what did I write? What did I write? So append this. Right. I just do part A twice instead of part A, part B. Good. Exactly what I wanted. Yeah. Cleaned out very nicely. Yeah, cleaned out very nicely. Right, and so basically, let's solve the problem. They are saying that this problem says that we just have to figure out how many of them have an overlap, basically, and this is fairly simple. So if you are trying to find out how many of them have an overlap, we definitely need a count variable, right? So let's even create that variable here and return it. And in between that is where we are going to do our processing, basically our solution. So what we're going to do is, first of all, for each pair that I'm going to receive, so I'm going to first iterate over this is 1, 2 inside. Right. So for each of them, I'm going to be receiving pairs. Okay, so for For each pair, what I'm going to try to do is, check to see if whether A is in B or B is in A, right? And once that is satisfied, yeah, and once that is satisfied, we can increase the count, right? So for pair in, I think I don't even need to write this one commented out because it is pretty much straightforward. So for pair in input data, what I really want to do is check to see if the pairs starting bound and ending bound, it's inside the part B's pair, right? Sorry, the part B's bounds, right? And so for this one, 2, 4, and 6, 8. 2, 4 clearly is inside. 2, 3, and 4, 5. 2, 3 is clearly inside 4, 5. No, it's not. Yeah, and how that is done is, if so for each pair, what I really want to do is check to see if this one is I'm going to define um, a utility method which basically does the thing for it, because I realize I'm going to do it twice, right? I'm going to check whether um, part A is inside part B and part B is inside part A, right? So yeah, so let's unpack it and then check. Um, and basically what I'm going to do is contain. This is going to be a utility method I'm going to write right up there. Is contained. Is contained takes two arguments, child and parent. And or same thing is contained then what we can do is if it is contained in our, then we can increase the counts, right? Else we just move on with our lives until we are done, then we can return the count. So this is a fairly simple problem. Let's write the is contained method. Let's define it over here. Define is contained takes a child and parents as its arguments. And what it's going to do is that it should first use the child's bounds, right? Yeah, so child into bracket 0, which means is greater than, yeah, for containment you need to check greater than. So greater than or equal to the parents. And child 1 is less than or equal to parents 1. And so I can return this. how do I spell return? Yeah, so when this is satisfied, then it means it is contained inside it. So let's run this code for the input and then see if we get 2. Right. We are supposed to get 2. Okay, why am I doing wrong? Okay, so the 2 runs, but not enough values to. But for yes, I think it is moving on to the second part, which we are not there yet. So yeah, so it works for 2. Let's go and get the input data and bring it over here. Just input and paste it here. And then now save it and then run the code again and it should stop complaining about. Okay, 4, 5, 6. So let's put in our 4, 5, 6. Okay, come on, one star. Let's continue to part 2. Part 2 says seem like there is still some. Let me just keep quiet and read it. There is still number of pairs that overlap at all. So in the above example, the first 2 pairs 2, 4, 6, 8 and 2, 3, 4, 5 don't overlap. Sorry, what? It seems like there is still quite a number of duplicate work planned instead. Instead, the elves would like to know the number of pairs that overlap at all. That overlap at all. That do not overlap at all. Is that what I meant? In the above example, the first 2 pairs 2, 4, 6, 8. Let's see 2, 4, 6, 8. And 2, 3, and 4, 5. How does 2, 4, okay, because 2 is not contained inside 6. Right. Don't overlap, right? While the remaining 4 pairs do overlap, right? Okay. So they want partial overlapping too as well. So we did total overlapping. Now they want us to do partial overlapping. Overlaps in a single section 7, right? Okay. All right. So in this example, that the number of overlapping assignment pairs is 4. So now we have to do the same thing, but then try and get 4 because now they want to not just get the total overlapping, but the partial overlapping too as well, which I think shouldn't be any different from the part 1. So part 2, let's define a special function called overlap, which will help us do the part 2. Overlap sticks to here they wouldn't be necessarily child parents, right? Because they will just be siblings that just overlap. So let's just say part A and part B, right? So the definition for overlap right now is if at any point in time, right, one of the ends, right, overlaps into the other one, right? That is your definition for overlapping. And so we only have to do it for one, and then put an all case inside our function. So basically what you want to do is pick up the bounds of part A, right, and then check to see if any of the bounds fall inside part B, right? So if part A, the lower bound of part A falls within the bounds of part B, I could probably just do a range and then check, part 0 inside it. But I wouldn't want to, have to. Yeah, this is a lot better because there is no looping happening. Here I want to check the lower bound and then the upper bound of part B. Right. And then if that's so, I'm going to return that yes, it overlaps some way, right? And then the flip too can be done, right? I can define it here, right? Or define it outside. Yeah, I can write the inverse of this, or you know, let's call this one partial overlap. F, and then use it here. So basically nothing is going to change, just the if statement that is going to change at this point in this case. Yeah, and everything's going to remain the same, but this part, right, is the only part that changes. And the condition is now going to be partial overlap. And then we do part A, part B. This one checks the lower bound is inside. How about if the upper bound is inside? Yeah, I didn't check that. Yeah, I probably don't need to do this. I just need to do it right here. And same thing, right? Unless I'm not getting it right. Let's look at the example that they use again one last time. 2 4 2 4, where's yeah, that 2 4 and 6 8, yes, 2.68 2 3 and yes, so that's the condition. Yep. So yeah, this should be enough. And so yeah, then we increase the count. So this should fix everything, and then run this for part 2. Wait, I needed to mute this inputs. Then run it with a test. 3. Supposed to get 4, right? Okay, so one of them is missing definitely. Let me mute part 1 running, and then also part 1 running from here. Let's just focus on part 2 for now. I'm getting 3. Why is that? Why is that? Why is that? Am I supposed to? I don't really think it would be necessary, right, to run the inverse simply because of how I have written the original one. Okay, so this one seems to work. I'll probably do some analysis to find out why later, but for now let me just some comments this and play the button 80808. So that should be it for the 2. Okay, so I'm done. Let's look at the board. Okay, seems cool. All right, so we're done. Thank you for tuning in if you did. See you again tomorrow, same time. Bye.